Okay, on your homework, you've got some problems, I think, 11, 12, 13, and 14, where you're going to approximate some roots. So I'll give you some examples here so you can see how to do these. Um, Not too bad, so hopefully this will help. Okay, the first one we're going to take a look at this. This is approximating roots, and we're going to use the linearizations to approximate the square root of 123 and the cube root of 123. So hopefully that'll be relatively straightforward. So let's take a look at this one. So first of all, the square root of 123, well, we're going to use f of x equal to the square root of x because this is the square root function, so I think that makes sense. And then what we'll do is we'll try to take a look at finding a tangent line to this that's close to the square root of 123. Well, the closest perfect square to 123 is 121, so I'm going to let x be 121. And that's going to be pretty close to 123, so if I make my tangent line to this graph, the square root of 120 of x, and I use 121, that's going to be pretty close to 123, and so the tangent line approximation should be pretty good. And we'll check the error on that. So we're going to basically use x to be 121. So we're going to find the tangent line. So f prime, that's just the derivative, so that's just going to be 1 over 2 times the square root of x. And then we're using x at 121, so my point of tangency will be 121 and f of 121, which is the square root of 121, which is 11. So my point of tangency will be 121 and 11. Now my slope, if I take the derivative to find the slope for the tangent line, I just take the derivative of x squared, which is, the derivative of the square root of x, which is 1 over 2 times the square root of x. Then I want to evaluate that at 121. So that's going to be 1 over 2 times the square root of 121, which is 1 over 2 times 11, which is 1 over 22. Okay, so that's my slope. So now I got my slope and I've got my point, so I just find the tangent line. That's all I have to do. So remember y minus y1 equals m, that's m, times x minus x1. So that's just the tangent line. Okay, the tangent line to the square root of x at the point x equals 121 and y equals 11. Okay, then all I did was I added 11 to both sides. I didn't really multiply this out because it's going to work out to leave it in this form when we make our substitution to find the approximation for 123. So it's best to leave it in that form, and you'll see why in just a second. Move this up a little bit. So this is what we got. So this is, I just solved it for y, so I put the 11 on the other side. And remember, this is the tangent line, y equals, and all you do is call that the linearization. That's the same thing. So L of x is just the tangent line when we set it equal to y. Okay? So this is my linearization, and this will give me a line that's going to, remember, if you looked at this sketch I showed you on the last couple notes, I think notes A. If you look at that sketch, you can see that this is going to be a tangent line, so its values will be pretty close to the value that we're looking for. So I'm going to put 123 in this. Now this is going to be a lot easier to evaluate, all right, than trying to find the square root of 123, which would be pretty hard to do arithmetically. So I'll put this in the linearization, 1 over 22. Instead of x, I've got 123 minus 121 plus 11. And 123 minus 121 is 2. So that's just going to be 2 over 22 plus 11. And 2 over 22 is 1 over 11 plus 11. So that's going to end up being 11 and 1/11. So what's 1/11? So I just did this, arithmetically without a calculator to show you that you could do it without a calculator. If I divide 1 by 11, I put a 0 there. 11 doesn't go in there, so if I add a 0, 11 goes into 199, goes 9 times, that's 11. Bring down a 0, it doesn't go into 10, but bring in another 0, I get 9, so I have 090909 repeating itself. So this is my approximation. Okay, 11.09. Okay. So how close is this to the actual value? Well, we can take the error, and remember the error is just the value using my calculator minus my approximation. Or this is f of x minus L of x. Okay, so I took the square root of 123 and I put that in my calculator, and then I subtracted this 11.0909. I might have put about 3 09s in there. And I got this, negative 3.726, let's round it off, to 10 to the minus 4. So I can write this as a fraction. Now remember, it's going to be absolute value, so don't worry about the negative sign. So this is going to be about 3.726 all over 10 to the 4th, because I can put that 4 in the bottom. And then rather than writing it out in zeros, I can just leave it in exponential form. I know that this is going to be less than 10, so this is going to be 3 is less than 10, or 3.7, so this will be less than 10 over 10 to the fourth, and I can reduce that by 1 to make that 1 over 10 to the third. And if I put that up on the top, 10 to the negative 3. So we can say the error is less than 10 to the negative 3, or within 1/1000th of my actual value. So that was pretty good approximation. Okay, and then you have another one. Okay, and this will be some more notes C, I would say. And we have example B where we're going to find the cube root of 123. So again, I want to find a perfect cube that's close to 123. Sorry, there should be x here. There should be x here. Okay, so let f of x be the cube root of x, or x to the 1/3 power. And we want to find a perfect cube, so the closest perfect cube to 123 is 125. The cube root of 125 is 5, so I'm going to use that. So my point that I'm going to use for my point of tangency will be x, the cube root of x, or 125, the cube root of 125, and the cube root of 125 is 5. So it's going to be 125, 5. So that's going to be my point of tangency. If I want the slope there, I can find that by taking the derivative and evaluating it at x equal 125. So if I take the derivative of this, I can write it in exponential form, x to the 1/3. And then if I use the power rule, 1/3 x to the negative 2/3, and I put that negative 2/3 on the bottom, this is my derivative. And then if I evaluate it at 125 to find the slope at 125, that's going to be 1 over 3 times 125 to the 2/3. Now remember, we're taking the 2/3 power, we root first, power second. So the cube root of 125 is 5. 5 squared is 25. So I got 3 times 25, which is 75. So that's my slope. So now I've got the slope and the point for the tangent line. So I write my tangent line, y minus y1 equals m times x minus x1. And then I just solve that for y, and there's my tangent line solved for y, and that's exactly the same thing as the linearization, just the tangent line. So it's not anything we haven't already done. Okay? So let's calculate this out, and let's not use a calculator to see what we get. And I want to find the approximation for 123, the cube root of 123. So it's going to be 1 over 75 times 123 minus 125 plus 5. Well, 123 minus, see, this is the easy calculation. See, this is a lot easier to do than take the cube root of 123. Without a calculator, I don't even know how to do. Okay, so we take the cube root of 123 minus 125, it's negative 2 over 75 plus 5. And then 2 over 75, I just divide 75 into 2. I put a couple of zeros there, start putting some placeholders in, and my 75 goes in there. It doesn't go into 20, so I put a 0. It goes into 200 twice, that's 150. And then I end up with 50, then I bring down a 0. I have some zeros to keep bringing down, and it goes in there 6 times, and I get 50, again 0. So I keep getting 6, 6. So I get 0.0266, and I keep all these 6s. Okay, now if I subtract that from 5, because this is negative and this is positive, so it's going to be 5 minus this to get a decimal. I get 5, which is 4.9999, all these 9s, and I keep subtracting all these 6s, and I get all these 3s, except here I get a 7, here I get a 9, and here I get a 4. So I get about 4.9733333333, etc. So that's my approximation. So that's the approximation for the cube root. Now let's check the error. Now remember the error, this is my calculator value. Now we can get out our calculator. And I'll take my calculator value of that minus 4.97333. And I think I put 4 or 5 3s in here. It was easy, just kept punching the 3s. And I get negative 1.435 times 10 to the negative 4. Remember, it's the absolute value, so it's 1.435 over 10 to the 4th. I put this on the bottom, and that's going to be 1.4 is less than 10 over 10 to the 4th. And again, I get 1 over 10 to the 3rd, which is 10 to the minus 3. So my error is less than 10 to the negative 3. And again, I'm within 1,000th. So that's a good way to find a pretty close approximation to the cube root of 123. And I have no idea how to do that without a calculator, so if I didn't have a calculator, that's one thing that will work. Okay, So if that helps, and that's gonna help you with those problems, numbers 11, 12, 13, and 14, so try those 4 problems.